Convert the following expression to rectangular form. Okay, 2,741 angle 261 degrees. Okay, so it is degrees. That's great. Let's put our little line here. So this is going to be, we're not talking about x and y coordinate systems. We're talking about the imaginary and the real part. And we got this thing at 260. Well, this is 270, so it's a little less than 270, 9 degrees less. So it's right there. I exaggerated that. And this size here is going to be 2741. Okay, and this angle here from the x-axis is measured at 261 degrees. Okay, now I would like to use this little angle, right? That little angle there. I know that angle right there is going to be, well, 270 minus 261 is going to be 9 degrees, okay? I like to use that one because it's the relative angle and it gives me always positive values. But some of you might want to use this absolute angle, and that's cool too. What's the purpose here? We need to find this y value here, right? We need to find this y value and this x value, okay? We can see that they're both going to be negative. Okay, so we're going to have negative, but I'm going to show you that you're going to get the negative values just by plugging in this 261 into your sine and cosines, but you will get positives if you put in this 9 degrees, okay? But you have to manually put that in there. So let's do it. So if we're dealing with the x-axis, we are going to be dealing with the cosine. Let's just make sure that cosine of, I always like to say this is what I'm saying. It makes such more sense if you're talking about the small one, because cosine of 9 is adjacent, which is this. Oh no, that's opposite. Whoa, what's going on here? Oh, you're right. See, this is going to be different actually. I would have to use this angle. This is where it makes it a little more confusing. So take my word right now that the x is going to be 261. Okay, so this is what I'm saying. It makes a little more sense to use this small angle. 261 is going to be the x over 2741. Okay, so this is using the absolute angle, and I don't suggest using it, but I wanted to write it down anyways. Now, if we used it the relative angle, now we're going to be like, oh, okay, see, this is measured from the y-axis. That what makes the difference. So we're measuring from the y-axis here. Now it actually flips. So now it's the sine. So x is going to be associated with sine. So sine of 9 degrees is opposite over hypotenuse. So sine of 9 degrees is going to be opposite, which is x over the 2741. Okay, so yeah, a little different here. 2741 sine of 9 degrees. Now, the only difference here is, like I said, if you use this absolute angle, this is going to give you not only the value, but it's going to give you the sign as well. So I guarantee you that this value here is going to give you negative this value, right? It's going to be a pretty small number because considering that's 9 degrees. And then this guy here will give me the same value, but it's not going to be negative. It's going to be positive. So I'll have to manually put that negative in there myself. Okay. Let's do the y value here. Okay. So here again, if we're using the absolute angle, y is associated with sine. So we'll go sine of 261 is equal to y over 2741. Okay. So y is equal to 2741 times sine of 261. Okay, and if we're going to use the absolute, or the relative angle, well, now we look at the little triangle, right? We flip our page, we look at the little triangle, and we say, okay, so cosine is adjacent over hypotenuse, and that's going to be this y. Okay, so cosine of 9 degrees is going to be to adjacent, which is not y over 2741. Okay, and again, the same things apply here. This is going to give you not only the value, but the sign, and this one will just give you the value, 2741, cosine of 9. And let's start plugging in some numbers, okay? So let's start at the top here. 2741 times cosine of 261. Okay, so that's going to give me the value and the sign. So it's going to give me negative 429. Okay, now, if we did 2741 sine of 9, 2741 sine of 9, we are going to get just the value. We're just going to get 429. Okay, so we're just going to get the value. We're not going to get the sign. We have to manually put that in. I prefer this way. I'm not going to lie to you. When I teach vectors, and if you look back at the vector quantities, I always use the relative angle. Okay, I like to put those negatives in manually. Let's do this guy. So 2741 times sine of 261. This is going to give me the sine and the value. And then this guy right here, 2741 times cosine of 9 is just going to give me the value. Okay. Okay, so let's convert this thing. A lot of explanation here. You know, if you actually just did this on a test, you just only have to do this section here, right there, and this section right here. You know, you can only pick, you don't have to pick one of them. You don't have to do both of them. I'm just showing you two different ways of doing the exact same problem, okay? So let's put our angle down here. So Z is going to be equal to X distance first, so your real distance first, and it's going to be negative. So it's going to be negative 429 minus 2707 I, and that I makes sure that these numbers cannot be combined. If I didn't include the I, well, you just take that one minus that one, and that would make no sense. You would have a single value, but no, this is a vector quantity, or it's a complex number, which is essentially a vector quantity, and that's that.